Hello everyone, this is Ari from Pantech Learning. So in the previous session, we have gotten into the topics, and today we are going to get into the topic of DAC. In previous session, we have seen the floating point unit, and we have interfaced the ultrasonic sensor, and we have found the distance. Okay, so we are going to get into the concept of DAC, which is DAC. What is the abbreviation for DAC? So it is a digital to analog converter. So as like same process like ADC. So it is going to do the process in vice versa. So ADC is going to convert the analog voltage to digital value. So what this ADC is going to do is it is going to convert this digital value into analog value. So where are we using these things? So you can see in a lots of media players they will be using the DAC because DAC is the main component for streaming the audio. So how this process running? So we will take one scenario. Okay, we will take one example. So I'm going to connect the recording mic to my microcontroller. So when I speak, it is going to generate the variable voltage. So this voltage is going to be get read by my ADC. So my ADC is going to read those voltages because my microphone is going to give the output in voltage, right? So I'm going to use the ADC and I'm going to read the analog voltage and I'm going to convert it into a digital voltage. Now, the audio of my what is the thing I have spoken is stored in the format of digital form. Okay. So, what is the next thing it is going to do is now I have connected the DAC, which is a digital to analog channel with this speaker. So, what it is going to do is now this digital value is processed into a converts the digital value into an analog value by using this DAC. So, the recorded voice of myself, it is in the format of digital form. So now this digital form is converted to analog form and the analog wave is given to the speaker in a variable voltage. So this is how the sound is produced, and this is how in all the media players you can see this is the implementation. So that is the main thing. Okay, and we will have a Kodak lot of things. So that is the initial stage for converting a digital thing into a audio format. Okay, so this is why we are using that. So next we will get into the DAC registers. Okay, so what we are going to do is we are going to create a sine wave. Okay, so we will create a sine waves using this DACs, and we will convert the audio file into a digital format, and we will try to read those digital values, and we will make the some sounds in the speaker. So this is what we are going to do in this session. So we will get into the session. Before that, so before getting into the next topic, now you can convert this masterclass into an internship, guys. So it is in a 1 month internship on embedded systems. So we are already learning the STM32, which is based on ARM Cortex M4 in a register level, right? So we are learning like in a register level. So it will be very much useful for you. So you can you have to when you have to improve yourself, you have to practice on these things. So while practicing, you need some internship like reference, like what are the ins, what are the bugs, all things you have to need some reference, right? So for that purpose, this internship is provided. And in what is the benefit of this internship is lots of topics you can refer to this internship, and lots of things going to be added in this internship, like CAN, LINs, lots of communications and tax core concepts all coming on the pipeline of courses. So don't miss this opportunity. Our fees is 1,200. So our discount price is 599. Okay. So you can use this ESMC1 coupon code, and by using this, you have to pay only 691 only. So by paying this fees, you can register for the internship and you can get more benefits. Okay. So now we will get into what are the benefits you will get. So as I said, so we are practicing lots of codes, right? So we are practicing lots of codes in the live session, and you are developing lots of core concepts. So you have to practice yourself for making to upskill yourself, right? So when you are practicing, you will come with some errors, or you will have some doubts related to those things, or you will after executing the code, you will not get output like this. So for that purpose, you can refer to those these 30 days videos. So what is the best benefit is the 30 days of masterclass live sessions will be available as a recordings in this internship. So and lots of topics also going to be added to those videos. So it will be accessible for those recordings will be accessible for 90 days. So you can use those videos as a reference for hands-on practice and developing a while developing a code. And even the concept is you are not clear with the concept means you can again rewatch it. So the concept will be get clear. Okay. So and what is the next benefit? So next benefit is we are going to do lots of hands-on practice on embedded projects, and you are going to implement what is the project I have teached you, and you are going to implement those in real time by yourself. So while developing the project, you will get lots of errors and lots of bugs. So you can in this internship we will provide a lots of practice on embedded projects, and you can ask the questions to clear the doubts to myself as a me. Okay. And what is the next benefit? So next benefit is you will get a 30 days of download presentations. So I am giving a presentation right for 30 days. So you will get this. Plus additionally, what you will get is what are the things we are using. We are using data manual, reference manual, programming manual, user manual, lots of things. So those are all the things what are we are using to develop the code, and all the things we use to learn the code concepts and communication protocols. All those files also will be included in these 30 days of downloadable presentations. So you will get the presentations as well as what are the things we are using for developing code and the projects. And also in addition, you are going to get a codes that I am developing. So I have developing a code in live sessions, right? So those codes are going to be .c files. It will be shared you as in a format of .c file. So you can refer to those codes also. So it will be exclusively available for these internship students. So you can use you can get those codes also. So you can use those codes for reference also. Okay. And what is the next benefit? Since we will have a one-to-one live sessions. So what is this? Is you can interact with me for 1 hour every Saturday class. So you can ask doubts. You can clear the doubts related to the topic which I have taken from the day 0 to till the date, or even you can ask the doubts related to the embedded systems out of the topics which I have. Now I am taking STM30, right? If you have a doubts related to the other microcontrollers, or you are doing lots of other, or you are involved in other embedded projects, you have a doubt related to those projects, or you have doubt related to this other microcontroller means you can also use those mastermind class to sessions to ask the questions related to the out of the session also. So you can ask the doubts related to the embedded systems out of this STM32 also. So you can use this mental life as these opportunities. So this is about how you are using your this opportunity, how you will make use of it. So you can also you can ask me to, you can also prefer me to do and take some new topics like some topics some core concepts you like to be learned, right? You would be want to learn those concepts. So you can say it in my Saturday class to me directly, so I can prepare on those topics, and I will be giving a presentation in this internship. So it will be very much exclusive for the internship students only. Okay, so those even out of the topic not based on STM, if you can ask if you want other topic more than out of this team is, you can also ask me that. So you can prefer me that. So I will take this. I will get into the topic and implement those things, and I will be giving you a recorder session for you, and also I will give a code on developing those things and if for while implementing in a real time. So these are the benefits you can get by this internship. So this is about how you are using this opportunity. Okay. So next is after registering, you will get an internship confirmation letter. So after registering, you will get a confirmation letter, and you are going to get a 2 e-certificates. What is this benefit? So you can use this certificates in the resumes. So what is the benefits? Is we are learning STM32 based on ARM Cortex M4, which is an industrial based controller in a register level, right? We are not using a advanced library, all libraries or some things which will be very much easy like Arduino programming. So we are getting into a register level. So it is in a from 0 to ground. We are starting from ground to advanced, right? So this is a basic step. So we have to know about registers to develop the all GPU like drivers. So we are learning STM32 in registers level. So this certificate will be very much useful for you. So what are the 2 certificates we are going to give? We are going to give 2 certificates. One is for participation and another one is for course completion on this STM32 register level. Okay. So it will be very much useful to you. So the internship fees is 1,200. So don't be afraid. So you don't have to pay this full amount. You can use this ESMC one coupon code so that you can get this 509 discount, and the discount fees is 691 only. Okay, so you can get the internship at 691 only. So this is the registration link, guys. This registration link will be available in the chat box. You can see this, and or you can see this description box. In the description box, this registration link will be available. So join as an internship user and use this internship as a upskilling opportunity for yourself. Okay, so we will get into the concept. We are going to see this. So the Pantech e-learning is offering a 100% placement for your students who was trying to get into the embedded engineering domain or Python domain, Java's data science domain, artificial engineers, and electric vehicle engineering. So these are the domains we are focusing on. The Pantech e-learning is focusing on these domains and providing a 100% placement for these domain-based industries and companies. So guys, you can enroll for this. This link and link will be provided in the description box and as well as chat box. Or you can also use this QR to scan and enroll. So you can join our team. Want to make a career as an whatever domain you needed. So what is the thing we are going to do here is we are analyzing the industries around us. So we are seeing what are the technologies they are asking from the students. What is the technology they have the industry required. So what is the technology that the industry needed. So we are analyzing those things, and as per the industrial requirements, we are training the students, and we are teaching them how to attend the interview and all the things, and we are giving them a 100% placement on based on the domain core industry. So if you take embedded, you will take a scenario of embedded engineer. So you will get a placed in the embedded domain. So we are the training is going to be based on the what is the as per the industry's requirements. So what are the technologies they are asking from the students. So those technologies going to be going to be get teacher going to train you for the this course for up to 3 to 6 months, and we are going to give you we are going to make you placed in this your dream companies. Okay, so guys, don't miss this opportunity. So you can enroll this. So enroll as soon as to get this. Lots of offers are going on. So you can enroll. Who's getting first will get the best offer. So register this and get a best offer and get placed in your dream company. Okay. 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 Now we will get into the DAC registers. Okay. So we will see this. Wait. So first we will refer to the data sheets. So you can see this is our hardware block diagram. So you can see we have an audio sensor and the audio DAC, and the audio DAC is connected to our mini jack. So we can connect our headphones directly. Okay. So what are the capabilities, onboard audio capabilities? We will see this. So we can give the sound can come independently from the different inputs, like microphone using the PDM protocol or analog when using the low pass filter. Then we can use this USB connectors for reading the storage, or we can store the digital values in this internal memory and we can read those things. The output can be given in 3 ways. It can be using the I2S protocol. Okay, so this is the protocol for audio processing. Then we can use this audio DAC as an analog output. Then we can use the microphone's output directly, use the low pass filter to analog input. So these are the things. Next, we will see the where are the channels. Okay. So you can see we have a DAC of 2 channels, which is a DA channel of 1 and channel of 2, which is in the PA of 4 and PA of 5. So this PA of 4 is connected to the ANT, means it is connected to the DAC and mini jack directly. So what is the next thing is we will get into these reference manual and so what are the features? The DAC module is a 12-bit module. The voltage output digital to analog converter. The DAC can be configured as an 8 or 12-bit mode. So maybe used for the conjunction with the DMA. So we can use the DMA also here. Okay. So we have a dual channel DMAs, sorry, DACs. So two DAC converters, one is output channel for each, and we have a left element and a right element options in a 12-bit mode. So these are the things. So what is next is we will get into these registers. Okay. So DAC registers. So we have a DAC control register. In this you can see the first 0 to 15 bit is for channel 1 and 16 to 31 bit is for channel 2. Okay. So you can see here we will have this 0th bit as an DHC channel DAC channel enabled, and we have an output buffer enabled. Then we can use this trigger or we can disable it. So what is the reason for using this trigger is we will see it in sine wave, because it is going to trigger the process. Okay. So we have to select which timer event we want to trigger it. Okay. So we have to select these timers in this trigger event. Then we can generate the triangle wave generation or noise wave generation. So we have to disable this wave generation for generating sine waves. So these are the attributes for what is the range you are using. It is 40 or 1023. What is the bits? And we have a 12th and 13th bit as a DMA enable and under an interrupt enable. Okay. So we are not going to use this interrupts. So we will see what is today we are going to use. Okay. So these are for trigger software triggers. So then we will have a dedicated channel 1 12-bit right alignment aligned data holding register, and we will have a 12-bit left aligned data holding registers. If I want to use this right side, I want to store the data in the right aligned means I will use this register. If I want to use it in the left means I will use this left register. Then likewise we will have for 8-bit both right and left. Then we will have a DAC channel 2, those are for channel 1, and we will have for channel 2, and we will have a register for dual channels. So we can send the data to the dual channels at the same time by using this register. So dual channel register. So we will have also for left alignment. Then we have a 8 bits. Then you can see we have a data output register. So we can we can use this register to read the data only, because we will send the data to this data holding register. So this data holding register is going to send the data to the this data output register after the one clock cycle. Okay. So we can't write the data to this register directly. So we have to write to this data register. Then it will send the data to this register in the one clock cycle of time. Okay. So then we will have a status register which will give a flag. So for channel 1, channel 2. Okay. So these are things we have to know about. Okay. So what we are going to do is we are going to create some sine waves, and we will create a code for processing the digital audio format to analog audio format. Okay. So what I am going to do is wait. So I have already created this. I have already created this. Added this library, and I have created a file in sinewave.c. Okay. So what are the functions we are going to create is, first we are going to create a function for GPIO, then we are going to create a function for void of DAC. Okay. Void. So these are the things we are going to create. Okay. So system for system clock configuration we will leave as it is, because it is running at the clock frequency of internal clock frequency of 16 MHz. So our system clock frequency is 16 MHz. Our APB1 and APB2 bus is also 16 MHz, running at the 16 MHz. Okay. So now we will. Okay. So first we will declare these as a static. So this will be accessible by throughout these programs. So what is this error? So now we are going to create the functions for these this GPA and DAC. First, I will create a function for GPA. Okay. So what is my function is void of GPA static void of GPA. So I'm going to create a function for this. So we have already seen this. I will get into this. So we have already seen this. The PA4 is in the PA4 is a DAC channel 1 output. So we are going to use this channel 1 only. So we have to configure this PA1. So what we have to do? We have to enable the clock for GPA, right? So it will be in the HB1 ENR of 0th bit. So this will enable my GPIO of 40. So what we have done is now we have enabled the clock for the GPIO. Okay. Okay. So what we are going to do is this is enough for GPIO function. We have just have to tune on the clock. Okay. So what is the next thing we are going to do is we are going to create a function for this. Okay. Okay. So what is next we are going to do is we are going to create a function for this DAC. Okay. So what are the things we have to configure in this DAC? So first we will go to the DAC registers. Okay. So in this DAC registers, first you will configure these about the control register. Okay. So you will see from the 0th bit. So what is the 0th bit is for to enable the channel of DAC of channel 1. Okay. So what is the next thing we have to do is DAC of channel output buffer. So we have to enable this output buffer. Okay. So next thing we will not use these triggers. Okay. So we don't want to set these and we don't want to set these values also. Okay. So we not going to use this DMA. So we don't want to set these things also. Okay. Okay. So first I will configure this DAC. First, what is the first thing we have to do is we have to enable this clock for this DAC tag. Okay. So go to this RCC, RCC of you will find which in which register the tag is. Okay. So we will go to the bus APB only. So you can see we have a DAC enabled in this RCC of APB1 bus in the 29th bit. Okay. So first we will enable this RCC of APB1 bus on left shift of 29. So it is right off. So enable clock for DAC. So is this bit is correct? Yes, 39 bit. So we have centered this, we have enabled the clock. So what is the next thing we have to do is we will get into the DAC. So DAC registers in this control register, we have to see this, we have configured channel 1, so we have to see this bits. Okay. So first we will make this control register as an 0. So to reset this, so DAC of 1 in this CR register, I'm going to make it as 0. So what is the next thing we have to do is now we have initialize the control register as 0. So this channel output buffer is enabled and this trigger is disabled and this also will be disabled and this wave generation is also disabled and this channel and interrupt is disabled. So what is the only one thing we have to do here is we have enabled this buffer, and we have to enable this. So we have to enable this. Finally, we have to enable the DAC channel. So we have to send this to on left shift of 0, right? So this will enable my DAC. Yeah. So this will cut as okay. So now we have finished the configuration for DAC. Okay, function for DAC. So what is the next thing we have to do is we are going to create a int main function. Okay. Wait. So we are going to create a void of new function which will going to enable my DAC. DAC of start. Okay. Void. This is what I'm going to do is I'm going to just enable my DAC. Okay. So what is the next function I am going to create is I have to set the values, right? So we have to set the values in these registers. So for that we have to create a variable. Okay. So what is the function I'm going to create is we have already so we are going to create a set value of in this what I have to going to do, what are the values I have to do here. Okay, so we will see those things. So what is the first thing is we are going to send these values to the right. I will get into the okay. Now what is the first thing I am going to do is I have already enabled this channel. So we will get into these registers and we will see what we have. So we are going to use this DAC of 12-bit right aligned data vaulting register. So I have to send the data to this register only. So what I am going to do is I am going to send these data here. Okay. For that I will make it as so what are the things you are going to send? So we are going to send the data. So it will be in uint of 32t. So in this I am going to send the data. Okay. Now I will send this data here. Okay. So where these values has to go. So go to these registers and we have to send these values here. Okay. So we are going to send these values to these registers to this 0. So what is the register? It is the DAC of 12-bit or okay. So DAC of 1 in this data register of 12-bit or 1. Okay. So in this data register, I have to send the data which will be left shift of 0. So this is going to send my data. Okay. So you will copy this and copy and paste. So now we have created the GPU functions, DAC functions, and DAC start and wait. This not DAC start and set value. Okay. So we need some delay. So for that we will wait. We will go to our we have these millisecond delay, which is for the software. So we will also declare this thing. Okay. So now we have given these delays. Okay. We have initialized the delay. Now what is the final step we have to do is we have to create this send main function. So void of increment. So before increment, we are going to declare some variables. So which is float of value. So my value is going to be value represents the voltage. Okay. So it will be 0.2. Okay. So what is the next thing I'm going to create is I'm going to create a uint of 32. In this I'm going to store some value variable. Wow. Okay. So what is the thing? So what is the thing next we have to do is we are going to call these functions. So what is the function I have to call as GPIO? So I will call these function. Next DAC. So DAC. So now we have to start the DAC, right? So DAC of start. Now we have started the DAC. Then we will create a while. So what I'm going to do is while of 1. So in this, I'm going to declare the variable var. What I'm going to do is I'm going to have the values. Okay, what is my value? So my value is 0.2. So it is going to be incremental. Okay, so I'm going to multiply it with this values. Okay, so star of 0 cross plus 1. So this is going to okay. So what is the next thing we have to do is we have to set the value, right? So set value. In set value, we have to send the data. What is our data? Our data is VAR. So VAR. Okay. So now we are sending this data. Okay. So what is the next thing we are going to do is we are going to increment the value. So we are going to increment these things. Increment the value by 0.5. Okay. So we will give some delay. So delay of we will give it 2000 milliseconds, which is 2 seconds. So it should not exceed 3.3 volt, right? Because we are operating voltage is 3.3 volt. So we are going to create a condition. So value is equal to greater than 3. Then it will reset the value is equal to 0.2. So it is going to happen. So now we have finished the coding. Okay. So what are the things? Okay. Now we will compile this. and we will see if there's any error. Okay, there is no errors. We will make this as a static. Okay, now we have developed this code. So what we are going to do is we will compile this code. Okay, we will upload this code. Before uploading, what we have to do? We have to go to the output. Sorry, go to the debugger and select the STLink debugger and go to settings. Set traces. So what is the megahertz? 8 megahertz. Flashes. Reset. Okay. So now I will connect my board. Okay. So what we are going to do is we are going to see the output in this. So we are going to see the output in 1 second. I'll connect this. So we are going to see the output in the digital oscilloscope. Okay, so which is DSO. So you will upload this code. Now we have uploaded this code. Okay. So what is this? This code is going to do is it is going to develop. It is going to make the ideal line from logic 0 to the logic 1 in the time period of 2 seconds. Okay. So it is what it is going to do. So now I will compile this and I will upload this code. Okay. So in today's class we have developed the code for giving a wave of logic 0 to logic 1 for a time interval of 2 seconds. So what we are going to do next is we are going to develop the code for creating a sine wave in the next session. So in next session, today's session is over, guys. So in next session we are going to see this code output in this digital oscilloscope, and we are going to create a sine wave, and we will create some. We are going to send the digital. We are going to convert this audio to the digital values, and we are going to send those digital values to the DAC. So we are going to play some audios using those things. So today's class is over, guys. So thank you for the session. We will meet on next session.